Hello, everyone. Welcome to our podcast entitled Global Standardization of Flow Cytometry Results with AI Systems. My name is Meindert Niemeijer. I'm the Chief Information Officer at Invivoscribe, and I'm here with Julian. And Julian, maybe you can introduce yourself.
Hi, I'm Julian D'Angelo, and I'm a Bioinformatics Manager at Invivoscribe.
Invivoscribe is a technology-driven international company. We have labs all over the world, and we're focused on oncology diagnostics, which means that we create products and provide services that optimize patient care and accelerate the development of therapeutics. I'll tell a little bit about my role before we get into the meat of the podcast. So, as the Chief Information Officer, I manage the bioinformatics, software engineering, and IT teams within Invivoscribe. So that means that, generally speaking, I am focused on optimizing the use of information technology, which includes AI, to achieve the company's business goals, right? And when I think about keywords to sort of describe my focus at the company, those keywords are, scaling, efficiency, automation, things like that. And today we are talking about a particular aspect of our product offering, flow cytometry. So we have flow cytometry labs all over the world, and that flow cytometry specifically presents an interesting challenge, right? Where we can apply AI. We are looking at expanding our footprint, doing more tests. And the tricky thing about flow cytometry is that there's a large sort of human interpretation component associated with it, right? Which makes scaling very difficult, and which makes differences in outputs between different machines, labs, operators, which makes that a challenge as well. And ideally, what you would want to have, especially for a company like ours, is that when we submit a sample, if we took a sample and we split it up and we submitted the sample in China or Japan, or we submit it in San Diego, you would want the output of all those samples to be exactly the same, right? But especially with flow cytometry, that's really a challenge.
Right.
Usually labs have what's called a flow master, right? The king of the flow domain, who he or she controls everything that goes on with flow. And that makes scaling or expanding that process much more difficult.
Yeah, and a little bit more on that. It just goes to the core technical issues with flow cytometry is the subjectivity and the diagnosis, right? And so, even if you have the capabilities and resources to scale by hiring more of these flow masters, there's still inherent subjectivity in how they do their diagnostic.
Exactly. And so, the key aspect here is that subjectivity, right? And maybe it's good for me to also talk a little bit about my background. So I have a background in medical imaging and machine learning. And for the last 10 years, I've worked in the medical device industry on devices that do autonomous diagnoses, basically. And sort of the core concept there is to take an activity that was done by a human specialist and using AI systems to replace that human, in that case completely. But there's many different levels that you can think about. You can look at an assistive AI, which means that the AI is helping the human with the data interpretation. Or you can look at going all the way to autonomous, where you actually replace the human. And there's other sort of intermediate forms, like you can have an AI look at just some cases. And that's actually a pretty interesting approach, where simple cases are reviewed by the AI, but more difficult cases are reviewed by humans. We were looking for how can we take this AI technology and apply it to this particular problem, because it seemed to be an excellent fit. So, given my background in autonomous AI, when I joined Invivoscribe, one of the things that I started looking at is, are there any of those type of items or those type of applications that we could apply AI to? And of course, the flow cytometry was a really good example because of the large human interpretation component. Now, to be clear, next generation sequencing has its own human interpretation piece to it, with the annotation team working on that. I think that might be a slightly more difficult problem to attack. So one of the things that I experienced previously is that you have to be very careful about how you approach replacing or augmenting humans with AI systems. Especially augmentation is really tricky, because you want to make sure that over time people start relying on your AI system, and if they start trusting it too much, you may actually lose a quality control component of having a human in the loop, right? And then you essentially end up with a system that is, partially autonomous, but was never really designed to be autonomous in that way. So that's something that we're very cognizant of. Other challenges are associated with, bias. I think, bias is an interesting problem. What I think is really great about Invivoscribe as a company and the situation that we're in is that we have extremely well characterized samples, a very high quality lab with, fully validated assays and tests, which really provides very, very high quality data for training these models. And, I think it's always important to make sure, when you're building models, just having a lot of data in and of itself is not, doesn't mean you will be developing a great model or something that solves an actual problem. Because if your data is not good or is not good quality, you might end up with a system that doesn't really work the way it's supposed to be working. So the fact that we have access to such high quality data, I think is a really great thing, and it has helped this particular project that we're talking about today move forward, I think, much quicker than it would have moved forward maybe in a different situation or a different environment. And then another great thing is that the variability and subjectivity between different tests, different machine, and very importantly, between different labs can be significantly reduced by applying AI in this manner. And I think that's really the thing that is driving this application for us as a company, being an international company and being really, I'm looking for the right word.
Harmonized.
Yes, being really harmonized, but also being very passionate about our standardization efforts, right? And really recognizing the value that brings to our customers. So I also want to talk a little bit about the technology, right? So what we've been focused on is we are custom building this AI using our internal data, right? So that means that we have a very talented and excited machine learning team on board that is using the data to create these AI algorithms. And the purpose right now really is to, the output of the flow machine is basically, it's basically kind of a point cloud. And the standard practice there is to use a process called gating, which is basically setting a number of thresholds in this, higher dimensional space, and then plotting the thresholded data onto 2D plots. So what we have built is an algorithm that can make those kinds of plots automatically. And it can also classify individual cells so if you take that information together and present it to the operator or the flow master, the idea is that this saves time, and we are evaluating whether it also improves the quality of outputs. It will certainly reduce the subjectivity quite a lot by doing that. And of course, if an operator or the flow master sees something that they want to explore further, with this approach, they are perfectly able to, still work with the data in the way that they're used to work with it.
I think one obvious reason for using AI in a flow cytometry application is the inherent nature of that data is easily adapted to an AI system, right? Because the data outputs are exactly what an ideal AI system would want as an input, because it has a vast number of different principal components or thresholds, as you were referring to for this gating system. It's more easily translated into a computational system. So the actual data inputs really lend themselves to an AI solution. Flow cytometry is really one of the first major applications that we can implement these AI systems at Invivoscribe. But the great thing is, our many arms that we have at the company in terms of R&D and a clinical lab and bioinformatics team and software. We're uniquely positioned to be able to capture the most value from these systems. And being in such a data-rich environment, data-rich meaning not just the quantity and each type of data, but a myriad of different data types. I think through this progress in personalized medicine, we're really discovering that no one method suffices, right? We really have to piece together and complement these diagnostic tests to get the best information, and thereby giving the patient the best information and leading to the best treatments or the best prognosis.
Yeah, I mean, I totally agree. In my view, one of the reasons this particular AI project is so important is because it represents really a key strategic strength for us that we are, further developing and refining over time. We're still kind of in the early stages. We have the first versions of our AI system up and running, then we are validating and verifying it. And of course, there will be some additional development and tweaking will be necessary to, for it to achieve its full potential.
Yeah, and I think Meindert, just to summarize that, we really are, because we are so vertically integrated, we're uniquely positioned to be able to tackle all the needs of our customers in a companion diagnostic or collaboration. We have all the capabilities ranging from manufacturing to R&D to manufacturing to shipping and receiving to a clinical lab to actually run these products, and a robust regulatory and clinical teams who actually have us abide by all these regulations and acquire all these high quality clinical samples for us to develop these tests with. The adding AI systems to the total package that we can offer really is more like a bow on the total package, because you don't need to go anywhere else but Invivoscribe to do these things from start to finish. We have over 25 years of experience and all of these facets of this development, from diagnostics to therapeutics. So our expertise is as high depth as it is breadth. So we have so many sites across the globe that have all of these capabilities.
Thank you, and hopefully we'll have more exciting applications to talk to you about next time.